students, faculty members, and institutional heads, they attend these lectures. And these lectures are also live streamed on all the UGC social media platforms. While many people attend these lectures in live mode, these lectures are also available on our social media platforms later for you to come back and watch them. Friends, you know that recently UGC has sent guidelines on the establishment of R&D cells in all the educational institutions across the country. And you will be glad to know that in hundreds of universities now, we have R&D cells. The objective of the R&D cells is to provide information to the younger faculty and the research scholars on funding opportunities, on how to run the projects, how to convert your basic research into a prototype and ultimately transform that into a product, even establish a startup company. However, as a research scholar, as a young faculty, when you embark on doing research in any given specific area, the first thing that you do is what kind of work was done on this topic by researchers in the past and what is being done now. And this process is called literature survey. You need to survey the literature to find out what is happening, whether your chosen topic has already been studied by many people, whether it is relevant, whether it has future applications. You need to explore many things by doing this literature survey. Only then you embark on doing research on a given topic. And for doing this literature survey, there are many databases that are available. If you are an electrical engineer or an electronics and communication engineer, you have IEEE Explorer. And that is a database I use extensively for my own research. And you have the Scopus database. And you have Web of Science. In fact, when I talk to my students in my classes, in the first class, I inform my students about the different kinds of databases that are available and how to search for relevant information in a very focused way. You can't just go to Google and search some keywords and search for information on your research topic. You need to use dedicated databases where you can search for information in a very focused way. So this is the first step for any research scholars to know how to use these databases. Web of Science is extensively used by researchers in India, just as we use Scopus and IEEE Explorer. Web of Index also has other facilities. It lists more than, I think, 11,000 journals, 11 or 12,000 journals. And using keywords, you can search for information from these journals on what kind of work is being published. But in addition to that, Web of Science also has a facility called InCites. Using this facility, you can do many things. For example, your research can become more meaningful, can become more productive if you collaborate with other people. Today, research cannot be done by a single person. It's always done by teams within the institution or by joint teams across the institution. So you need to collaborate with people, with researchers. So how do you collaborate? You need to find out which groups are highly productive, which groups are relevant to your own research, And some of that analytics can be done using this InCites tool. And it will also help you in increasing your own productivity if you can effectively collaborate. It will help you to showcase your own research, your institutional research, which will help in recognizing your university as one of the productive organizations in a given area. It will help other researchers also to identify your institution. So today we have an expert from Web of Science. Her name is Subhasree Nag. We have invited her to speak about this tool so that our research scholars, young faculty will become more aware about the usefulness of some of the tools that are available. We will have a brief lecture by her, maybe for about 30 minutes or so. And then if there are questions, the audience can raise those questions in the chat box on our social media platforms, and my team will pass on those questions to me. Or you can raise your hand electronically on the screen, and our team will unmute you so that you can put your question. So I now invite Ms. Subhasree Nag to deliver her presentation.
Thank you, Professor Jagdish Kumar, for the very nice introduction to the topic. If I can get the share screen. Yeah. Can I have a small confirmation from everybody who's attending this webinar that they can see my screen?
Yes, we can see it.
Yeah. So first of all, thank you again, UGC, for inviting us to present. Today, what I'm going to talk about is how you can improve your academic ranking and performance using some of the Clarivate tools. Now, I represent Clarivate, which is the proprietor of Web of Science and InCites, but this lecture will also contain a lot of common tips that researchers and university leaders who are attending today's session can use in their pursuit of creating and performing impactful research. I think the first slide is very, very self-explanatory. In a survey of major funding bodies across the world, especially in Western Europe and Northern America, it has been seen that today, on an average, 1 in 6 proposals are just funded. This number could actually be lower in the case of India. And what is being noticed is that most university leaders, and I'm sure a lot of you today will agree, that we do not really use evidence-based metrics to inform decisions about research strategy, what avenues of research should we pursue, or how do we attract talent, retain talent. These are made on a very qualitative basis. Today's discussion is more about orienting all of you using different databases and tools, how you can make more evidence-based choices with regards to your research strategy formation, creating impactful research, where do you publish, making sure your research reaches a wider and a more targeted audience of your choice. Now, today's discussion is centered across rankings. I am sure all of the universities here, we all pursue some kind of ranking in order to increase our reputation, really cement our place in the scientific and research community. Now, what we have seen for university rankings across the world, and I am not taking any particular ranking agency over here, but over the world, internationally, nationally in case of NAG or NIRF, internationally there are several. There is US News, there is the Shanghai Jiaotong rankings, you have THE, QS, different rankings, whatever they are, most of them have certain standard metrics. They talk about number of publications in index journals. When we talk about indexing, there are different citation databases. Professor Jagdish mentioned them in addition to Web of Science. These ranking agencies look for the presence of publications in journals appearing on these databases. So number one, we need to make a shift in our mentality from just accruing number of publications. These publications should be in journals that are on these databases, because these databases typically are curated. They reflect what the scientific and research community is looking at, which kind of literature they're looking at, which kind of journals they are looking at. So it is very important that we disseminate our research accordingly. Now, they also look at not only how many publications you have. Very, very important is they also look at how many of your publications are at the top of your field. How many of your researchers are highly cited, or they are in the top 1% by citation impact. Now, Clarivate every year publishes a very, very highly acclaimed list of highly cited researchers. You can just type in highly cited researchers, have a look at them. India has often not been in the top, though our research production in terms of quantity, the quantum is very high. By number of papers, we are in the top 10, but by number of highly cited researchers, we come much lesser. So that is a very important parameter that most ranking agencies look at. What is the impact your researchers are making? Then they look at citations, they look at patents, they look at research income, several of the data. So this is something that I think this metric, this slide should serve as a kind of a guide that what are the areas that I need to focus on if I want to be a part of the rankings game, if I want to ensure that my institution, secures a high ranking, it is there in the league of the big universities. So this is what the universities look at. Now, as a university head, or what do I, as a university leader, what do we need to measure? What should we strive for? Now, that's where we're coming for. We need to benchmark our research against peer institutions. So it is very important, this term over here, peer institutions. If you are, so when I talk about peer institutions, let's say in India, when an IIT, because they are institutions of national importance, they have a different level of expertise, funding. A smaller state university probably cannot compete with an IIT right away. So as an institution, the first step you need to do is, if I am a small state university, what are the other universities which have a similar scope of research, similar scope of funding? Who are they and how do we compare against them? Comparison with a much more established university can be aspirational. But when we start to understand, as Dr. Jagdish very rightly mentioned, it's very important to know when you're looking at a project, what have other people done before you? Similarly, when you're trying to understand where you are as a higher educational institution in your research journey, it's very necessary to know what have you achieved and how do you compare against other institutions of the same stature. We need to assess our existing and potential collaborations to find the best partners and demonstrate successful outcomes to funders. There are also today goals about measuring our progress towards open research, and that is something we will address subsequently. Now, over here, what I'm going to talk about are two platforms. We'll start with Web of Science. Web of Science is something that several universities today in India have access to. But the point we are trying to make is, are we all using this database, which is actually very, very powerful in the right way? Now, what can Web of Science help you do to understand or do what we call a SWOT analysis? It can help you identify the right projects. It can help you identify the right journals that will result in increased citation impact and choose the right partners to collaborate with. Web of Science, by the way, has huge access to repository material and can help you satisfy a certain part of your full text needs, and that can reduce your library budget, again helping you strategize your research. It can help you track key opinion leaders and secure external investment by looking at what has been happening in the field. So before I'll just take 10 minutes and show you live on the platform that how does Web of Science work. But just before that, let's see what does Web of Science entail about, what are its features and data sources. Many of you have used Web of Science, probably every day in your research. There have been a lot of improvements in the past 1 year. If you do not know them, I really recommend you just going. We have several blogs. You could write into us. We'll be glad to let you know what the improvements have been. But today, some of the most interesting things that are available on Web of Science today are, as you can see, we have 1.7 billion cited references. These are things that we know. But very interestingly, today we cover even preprints. So Professor Jagdish, he comes from an electronics engineering background. For many of us today who are attending this session and who are in science and technology and engineering, especially these fields, you know the importance of preprints. Preprints are publications that have not undergone the formal peer review process as of yet. But this is a great way of looking at cutting edge research. They are very commonly accepted, especially in the physics, mathematics, and engineering field. A lot of research, it has been a tradition of these researchers publishing preprints or uploading preprints onto the platform, like platforms like Archive, etc. Now, what Web of Science is doing is it is collecting the preprints from these repositories and connecting them to citations. It is also letting you know that, yes, this is a preprint, but a published version, a formally peer-reviewed published version of this preprint also exists, and you can search it. This is searchable, analyzable using all the Web of Science algorithms. Very interestingly, we are now going to include dissertations and theses on the Web of Science platform from June, July onwards. So as a researcher, you can get access not only to traditional peer-reviewed literature, but also access content, which is outside journal articles and conference proceedings. We have now document level classifications and citation context embedded. So with this, I will just stop sharing and I'll just go on to my Web of Science platform. Okay, so this is how Web of Science, I've done a simple search. I've done a simple search on bioethanol and cellulose for all of us who do not come from a science background. Bioethanol, it's a biofuel. So as a biofuel, it is alcohol or produced from any kind of biological sources from cellulose. And I've just done a simple search over here. Now, what does Web of Science help you? And this is where you can utilize a database like Web of Science for your literature search and identifying gaps in research. Now, if you look over here, there are 3,000 publications, and Web of Science allows you to do a very thorough document level classification. Now, if I wanted to understand, now this is done in a hierarchical fashion. So we have macro topics, which are related to the very broad field of engineering, agricultural sciences, life sciences, etc. And that is followed by meso, which is a 300 plus categories classification. So you have classifications like paper and wood material science, crop science, etc. And then you go to a much more granular micro classification. So why is this very helpful? So again, tip number one for doing a literature search. A literature search should always start out being very broad. When you use a database like Web of Science, which is just not based on semantics or on keywords, which has citation connections, you can actually, so these document level classifications have been done using artificial intelligence and citation patterns. We have clustered papers which cite each other, and based on the commonality, we have given topic areas. Okay, so for example, if I look at this 3,600 data set, I can see that these are the micro classifications based on the way these documents are citing each other. Now, how does this allow me to understand research gaps? Now, if I notice over here, there are in bioethanol and cellulose formation, one of the things that you can be used to break down the cellulose in the wood or paper pulp in order to produce the alcohol could be something related to algae. Like I can use microalgae, I can use algae-based enzymes to do this conversion. But if I notice over here, microalgae, there are only 19 papers. Okay. If I look over here, there are very few papers, but there are some papers which are using carbon dots. Now, this is a great way of identifying which areas in a certain data set or topic are saturated, which are not. Okay, so this is a way you can quickly understand and, refine and identify research gaps. If I go back, now, what I can also do is I can slice and dice this set. I can say let's go by citations highest first, and I can create a small subset of the top 100 papers and see which citation topics they belong to. So what does that actually tell me? That tells me people who are working in this area, whose publications are very highly cited, what are the topics are they working on? Because these could mean that these are the topics which have a higher tendency, or which have a higher probability, right word would be higher probability of getting funded. Okay, so this is the kind of analysis I would not be able to do if I had to use, let's say, Google Scholar. Next, if you notice one thing about a citation database like Web of Science, many times the high number of citations actually do not tell me about the relative importance of a topic in that area or the paper in that area. How are other people citing that paper? Are they using the results in that paper to support or contrast with their work? Or are they using the information in the paper just as a background? Now, background papers which are cited in the introduction section in the background, they are important, but they might not have specific nuggets of information that can help you in a research. I would place more importance maybe to publications that are being cited in the discussion. Now, for the first time, if you notice over here, this is something, if you have not explored on Web of Science, please go and explore. We have a citation class. What we have done is you have used our AI clustering technologies to actually see which papers are being cited in the discussion. So, for example, this paper is cited in the discussion most number of citations are coming from discussion. I can click on this record, and it tells me which are the publications. So 86 papers citing it in the discussion section, and this is a great way of quickly understanding. And you can also see the in-text mention. right? So this is a great way of understanding how has a certain publication influenced research over time. So if you notice over here, I'm not looking at all the publications that have cited that paper, but I'm looking at cited papers which have cited the publication I was looking at, the parent publication, in their discussion section. So try and use Web of Science in this way. Web of Science also, let me just quickly show you how preprints are searchable on Web of Science. So I can go to my preprint citation index. It allows me to search using different categories. So if I say I want to search on artificial intelligence, search. And it tells you what are the references that they have cited. So it gives you citation connections with already, established literature. Now, going forward, I would also like to showcase a very interesting tool. I do not know how many of you have probably used it before. It's a tool called as VOS Viewer. VOS Viewer, as you can see, it is being developed by scientometricians at Leiden University, Netherlands. It's a great tool, according to me. What VOS Viewer actually helps you do is, you can extract data from Web of Science. There are other citation databases which work with VOS Viewer. So if you are from the biomedical field, PubMed works, other citation databases also work. But please remember the data quality will be better. The analysis quality on VOS Viewer will be better depending on how well the metadata is classified. So Web of Science really works well with VOS Viewer. What VOS Viewer is doing, what I have done over here is, I have chosen publications from 2017 to 2020, which appear in India from Indian institutions, which are on artificial intelligence, which are classified under the broad Web of Science category of artificial intelligence. And I have chosen the top 500 cited papers. Okay, I want to understand what are researchers in India, highly cited papers from India, what are the topics they are focusing on? And based upon the keyword co-occurrence, so how are keywords occurring in different publications? How are they occurring with each other? What are the connections? I get to have a network map. And if you notice, there are some different colors, right? Now, the warmer the color becomes, that means it's a newer paper. So you can notice deep learning based on the size of the node. This is one keyword that appears in several different papers. And deep learning is accompanied, or it is, associated in the papers with keywords like this, right? So I have deep learning in a paper that also is associated with, let's say, fault diagnosis. Fault diagnosis is associated with another paper. There's another paper probably which has a term fault diagnosis along with Dempster-Schaeffer evidence theory. So you can see how the connections are building. So you can understand what are the keywords which keywords define the content of a paper. So how is the content in the data set related to each other, the ideas related to each other? And you can also see the newer papers, what are they focusing on? So I can see task analysis is something which is new. Newer papers have that term. The older papers do not have that keyword in there. This is a great way of actually analyzing a big data set. By the way, VOS Viewer is absolutely free. There are other different visualization software available. There is CiteC by Drexel University. There is Pajek. There are different softwares available. I have personally felt that VOS Viewer is very user-friendly, simple, user-friendly, also trusted by the academic community, because if you just do a survey on Web of Science of how many people have used VOS Viewer in their methods section of systematic reviews of literature in a field, you will see VOS Viewer as a term cropping up very often. So it is something that is used by a lot of researchers. So it has credibility in the field. So I would really recommend all of you to just have a look at the software, try to understand big data sets. This is a great way of understanding where is research in your field going through. So the first thing, how do I select and identify the right projects to embark on? Web of Science and tools like Was Viewer will be a great combination to identify the projects, the newest projects, the most highly cited projects, or what are people working on. Look at preprints, look at publications in the top journals in your field. What are people? Preprints also are a great way of, and you can do the same thing on Was Viewer. You can download a data set from Web of Science from the preprint collection and analyze and see what are people working on. Going back to our presentation. So I believe these are some of the ways that you can use Web of Science. Now, Web of Science also has retrospective funding information. This is something that I would really recommend everybody when you're starting on a project or as office, researchers, research office. What are the kind of topics that a particular funding agency has funded in, let's say, the past 5 years? So if I go back to my Web of Science platform, just to show you, I can do a search over here on Web of Science, and I can go to funding agency. And let's say I say for funding agency, CSIR. There are 113,000 publications from CSIR in order to make sure that I am not let's make sure that we are choosing India. And now what I'm going to do is I'm going to look at, let's say, the last 3 years. And in terms of volume, if you notice over here, CSIR is highly invested in publications related to chemistry, synthesis, pigments, inorganic chemistry, electrochemistry, photocatalysts. So quick overview of what kind of research. What if you would like to understand who are the people who are publishing research, which is funded by CSIR, all you need to do is come over here and you can see. Now, this is obviously, these are the CSIR labs, but if you look at the IIT system, University of Delhi gets a lot of funding. You have Punjab University. It will be, these are of course other collaborators. But if you look at the Indian ecosystem, you can quickly identify. And again, go back to the filters. Let's say choose pigments, see what are the highly cited papers funded by CSIR in the area of pigments, who are the institutions working on them. All of this takes just 5 to 10 minutes, but gives you a very good idea of the research landscape. Now we come to the most important question, and I will be discussing this in a little bit of detail. Where do I publish? In order to actually create impact, whatever research, once you have identified the project, you have done the project, now is the time to disseminate the results. Where do I disseminate? Where do I publish? Should it be published as a conference proceeding, as a journal article? Where? Now, the first thing you must remember is your target audience. If your target audience is somebody who is more industry specific, whom you think you should be, you want to just get your research out there onto the public domain, and network with people or use that as a way to maybe gain funds, maybe, as the Professor Jagdish Kumar said, startups, incubator centers, where you need to get your idea out there in the open, network with people, and maybe get more funding, which where you can flesh out your research. Conference proceedings are a great way to start. A Web of Science has a curated collection of conference proceedings where we look for quality. We ensure that these are not predatory conferences. These are not conferences that are low quality. These are going to be attended by key opinion leaders. So you could look at the conferences. You could look at conference proceedings which have been highly cited, which have proceedings papers which are cited heavily by other researchers in your domain, and thereby decide where to where to send your abstract to. Second, we come to the manuscript. I think all of us agree over here. One of the biggest, factors while publishing is a journal impact factor. What do we mean by the journal impact factor? If you notice over here, it's a simple calculation. It's basically the citations that are accrued in a particular year divided by the number of publications published in the previous 2 years. So if I am looking for the JIF or the impact factor that is going to appear in 2023, we'll come up with the edition in June. Every year in the month of June, we come out with the latest new impact factors. So those journal impact factors, so for 2023, it will be the citations accrued in 2022. For what? For the papers that were published in the previous 2 years, that is 2020 and 2021. Now, if you notice over here, the journal impact factor obviously is going to be higher for journals whose publications have received a good number of citations. So it is a proxy of the citation impact. It's a surrogate proxy marker for the citation impact in the field, right? And journals which are more exclusionary, restrictive, which publish lower papers, but their publications garner a lot of citations, these are the ones which have higher journal impact factor. But now let us interpret it. When I say a journal impact factor of, let's say, 3.45, random, how do I know it's a good journal or a bad journal? It all depends upon the subject area. Please remember, there's something very, very important. Nobody should take the journal impact factor in isolation. No, journal impact factor should be tied into the area of in which that journal appears. So for example, mathematics niche area doesn't get that many citations. Journals in that category typically have lower impact factors, whereas something which is very interdisciplinary like nanoscience or maybe something biomedical science or pharmacology, they have high impact factors. So let us look for the scenarios for publication. If you are trying to publish, please don't look just at the journal impact factor, look at the quartiles. Now, based upon the location of your journal in a particular subject area, when we sort it by impact factors, so let's say in mathematics, we have 50 journals. Those doesn't matter. The top impact factor for these 50 journals is just 2. If your journal comes in the top 25% of those 50 journals by impact factor, then it is said to be a Q1 journal, quartile 1, so on and so forth. So when you are deciding to publish somewhere, the idea should be, am I publishing in a quartile 1 journal? Is my journal ranked high enough in my field, rather than just this arithmetic ratio called impact factor? There's an amazing tool called the Journal Citation Reports that gives you an idea about how the impact factor is, trending across years. So, so for example, for a journal, is the impact factor increasing or decreasing with time? That gives you ideas whether, if a journal's impact factor is going down with time, that should give you pause. Why is that happening? Is that happening to other journals in the field also, or it is just only to this particular journal? If so, should I be publishing over there or not? So when you look to publish and understand the impact factor, please understand it is subject dependent. Earlier, the impact factor was given only to those journals which were in the Science Citation Index and the Social Sciences Citation Index of Web of Science. Now, Web of Science has subject-specific indexes. Now, we are extending the journal impact factor from 2023 onwards to every journal on the Web of Science. That is 21,400 plus journals, all of them will receive an impact factor. Now, these are very important things to remember, because please remember, for NIRF ranking purposes, anything which is published on the Web of Science core collection is taken into consideration for your research productivity parameter. And from 2023 onward, the impact factor calculation will be there. Look at that. There is a free database available from Clarivate called Master Journal List. Please look into the Master Journal List to verify that your paper appears in the Web of Science or not, because until and unless your journal is there on Web of Science, it cannot receive an impact factor. So don't get fooled by misleading metrics which are there on the web. We also have essential science indicators. Basically, essential science indicator just tells you where science is going. If you are a Web of Science research, a subscriber, do not have essential science indicators, nothing to worry. Just as I said, you can always take a subset of the top cited papers in the recent years, look them up on VOS Viewer to find out what are the trends, what are the areas they are covering. Now we come to another important part, which is research evaluation. We have talked a lot about how do we embark on the right project, how do we understand where should we get funding from, where should we apply for funding, how do we look at the top researchers in our field. These people could be, or key opinion leaders. You can track them, you can collaborate with them. We have a tool called InCites. Basically, what InCites does is, InCites also works with the Web of Science data, but we normalize the data. We normalize the data in terms of subject area, year of publication, and the document type. As you saw with journal impact factor, citation patterns rates are different for different fields. So it is very difficult to compare, let's say, a mathematics researcher with a biomedical science researcher, or an arts and humanities researcher with somebody from the biomedical sciences or maybe material sciences. However, if I can normalize them and remove the bias from subject areas, that is going to be very helpful for measuring output and impact. One tip, please do not use journal performance or journal impact factor as a proxy for paper performance. You could have published a paper in Nature that shows that your paper was rigorous enough to satisfy the needs of the journal, but is it really important in your field will be determined by the citations it receives. Just having a Nature paper does not tell you that that paper is extremely important to your field. Okay, so journal performance should never be used as a proxy for paper performance or for an individual's performance. There are several people who publish very important publications, but that do not necessarily occur in the top journals. A great example would be Sir Venkatraman, who defined the ribosome structure. Several of the pioneering publications actually appeared in smaller journals, which were eventually highly cited and which were cited by some of the top, papers in the field. Cumulative impact factors are not the best practice. If you tell a researcher what is your total cumulative impact factor in which you have published, remember researchers' fields change, And therefore, the impact factors of the journals where they choose to publish also can change. The total cumulative impact factor is not a best practice. Whenever you are trying to compare people, try comparing with absolute citation numbers. Does not give you the whole picture. You need to normalize the parameters. And for that, we have a tool called InCites. And I will actually be now going in and showing you what you can do on InCites. You can actually analyze productivity, trends, key categories. You can understand collaborations, journal utilization, and most cited documents. Let's try to see how you can build your analysis on InCites. Now, InCites allows you, so you can actually go to InCites and say for a particular organization, okay, it could be any organization, you choose a particular time period and decide how many documents are there, how many times they're cited. You can say which kind of organization you are looking at. So for example, on InCites, an IIT is an academic institution, whereas CSIR is a research institution, because a mandate is different. CSIR is more geared towards research, whereas IIT is a degree granting institution. So that's an academic institution. Now, to exemplify what I mean, I just have some sample analysis over here. So, for example, Indian Institute of Science, I've chosen Indian Institute of Science. I'm choosing to see what does Indian Institute of Science, whom does Institute of Science collaborate with. In terms of research records, if you notice over here, TIFR, it collaborates with, it has 850 publications. One of its top collaborators is TIFR. Now, if I look at the normalized citation impact of these co-authored papers, then I go and I see that Saha Institute, so look, just a minute. If you see, SINP has fewer number of papers, but in terms of the impact that has been created, that is more high with Saha Institute of Nuclear Physics. Now, I have not shown this analysis over here, but if I went to InCites and I reduced the number of authors, if you go over here, you can see we have authors per document as a filter. If I decrease that number, if I reduce that number, and I say that I don't want to look at papers with more than 30 authors, you will notice that all these collaborations will disappear. And if anybody has a guess to why this happens, that's because IISc, SINP, TIFR, they're all part of these big multi-geography collaborations like Atlas and CERN, etc. Right? They publish a lot of influential papers in high energy particle physics. But if I wanted to look for papers where the idea is being generated at IISc and executed. So I'm looking at two things. I'm looking at whether the reprint author or the corresponding author is from the institution, and I'm looking whether the first author, which typically is the postdoc, early career faculty, or the graduate student who is responsible for doing the major chunk of the work. If I put those two filters in place, then I will not see any of these. So I can now have a good idea that IISc's citations or its most impactful work is driven by what kind of publications. This is the kind of level of analysis that will be very helpful to really champion certain departments or certain projects at your university. Just the total number of citations from an institution does not always tell you the whole story. And for that, I have a great slide for this one, where we deep dive into the quantitative data. Now, I have chosen for an example, All India Institute of Medical Sciences, a top medical institution in India. Now, if you look at their publication from 2017 to 2021, 5-year period, impressive 14,000 publications with a very, very impressive 102,000 citations. Okay, so on an average, every paper is being cited at least more than 6 to 7 times. However, look at this metric. 56.08%. That means that's a huge tail. Almost 7,000 publications do not have even one citation from AIMS. Okay, so this now if I do what I have done here is, can you see over here? The next thing, I have limited my authors per document to 1 to 50. And I have said that the corresponding and author should be from All India Institute of Medical Sciences. When I do that, the paper count is not so different. Only 3,000 papers disappear. That means there are 3,000 papers where AIMS researchers are typically co-authors, and they are these big papers. In the clinical sciences, you just like high energy particle physics, you have these huge multi-geography papers. So if I take those 3,000 publications, just now look at the citation rate, how low it has dipped. And now the normalized citation impact, which was better than average in the first case, drops down to 0.62. This is a great way of going into insights and deep diving into your institution's data to understand where you are. Where are your strengths? Where are your weaknesses? Where are your opportunities? Use evidence-based metrics. A lot of this work, if you have the computing power, probably you could do on Web of Science, but mostly InCites, because it can synthesize hundreds and thousands of documents at the same time, calculate the weighted averages to calculate these normalization parameters. They give you these data points or these insights very quickly, very reliably. So with this, I will just like to conclude. When you are looking for academic rankings, when you are looking to evaluate and manage research, what are some of the best practices that you should follow? I have a QR code over here. This QR code should link you to a seminal paper by David Pendlebury from the ISI, Clarivate, who has written on quantitative metric evaluation, etc. 10 rules in using publications and citation analysis is, first of all, formulate the question. Just like in research hypothesis, formulate a question and understand whether the available data can address the question or not. For example, if I wanted to understand whether in India, women engineers are publishing as frequently and as impactfully as male engineers, probably this data cannot do that. I would need other software which can process the names of the authors, and then I would use it with Web of Science. Just Web of Science data cannot give me that information, right? Choose the right publication types, field definitions, and the years of data. Decide on whole or fractional counting. Fractional counting is when we look at Web of Science or InCites, these all work on whole counting. That means if a paper has 10 different affiliations associated with it, and the paper has 10 citations, every affiliation gets the benefit of 10 citations. Okay, every affiliation gets the whole chunk of the citation credit. We are not fractionally counting. Some researchers now advocate for fractional counting, saying that if a paper has 50 authors and it has 50 citations, every affiliation, every author, should just get one citation credit. So 50 divided by 50. Okay, the jury is out there. There's still no concordance amongst experts whether this is the right approach or not. So you need to decide that. Judge whether data requires editing to remove any artificially, So if there is any data which is any publication which is an outlier, maybe this particular author has published this one paper which has 5,000 citations. Other papers just have 20 or 30. And that paper, this author was a co-author when he or she was a postdoc in a very, very reputed lab. So that one paper is going to skew the other metrics. So just like in a good research design, when we look at statistics, even in citation analysis, we need to understand that any outlier data does not skew our analysis. Use relative measures, obtain multiple measures. Only one measure cannot define a research institution or a researcher use multiple measures to create a profile. And that is exactly what the university rankings try to do. They look at perception, they look at number of faculty, they look at citations, they look at patents. So as when you are trying to build this in-house evaluation system, go the same way. Confirm whether the data collected are relevant and ask whether the results are reasonable. So with this, we conclude our talk and we'll be open for questions. Thank you so much for being a patient listener.
Right. Thank you. Thank you very much, Ms. Subhasree Nag, for a very detailed presentation on how to use these resources in the research work of the institutions and also the individual researchers. Let me now see if there are any questions from the audience. Let me see if I have received anything. Right. Are there any questions from the audience? You, of course, can watch this lecture again on our social media platform. You can raise your hand electronically. Right. Please unmute yourself.
Sir, I am Manoj here. Am I audible, sir?
Please go ahead.
Manoj from InFilmNet Center, sir, senior scientist. Thank you so much, Honorable Chairman. And Dr. Subhasree Nag giving a very impressive highlight on the research aggregation you are doing with Web of Science as well as InCites. I'm very happy to hear that you are integrated with AI clustering technology for this InCites. And InFilmNet is a user of 100 of our institutions are using Web of Science, but InCites I need more clarification and maybe more training to understand, especially when you can listen to me, no, Subhasree ma'am?
Yeah, yes, sir. I can listen to you.
So I think this category-based normalization citation impact you made it.
Yeah.
That I have to practically check it. And for highlighting it, thank you so much. And Clarivate is going to be partner with us in the next international conference on ATD. And you have already mentioned about 5 million dissertation will be part of this.
Yes, absolutely. So the 5 million dissertations, we will release it just like preprint citation index. We will not put it in the core collections. We are not contaminating traditional peer-reviewed literature. We'll have another citation index added on to the Web of Science platform, and that will have all your dissertations and thesis. So if you would like to, know what is the current state, or you want like to know some research topic and how it is reflected in dissertations and thesis, you'll be able to search it on the platform. And
right.
And it will be analyzable. It will have all the filters. Am I audible?
Yes, you are audible.
Yeah, so you will be able to search it. You will be able to, if for example, I'll just again take the example of artificial intelligence. If I want to see what are the newest dissertations and theses coming out on artificial intelligence, that is perfectly searchable. Again, these will have keywords associated with them. So if I would like to take a big set of data and put it onto some kind of visualization software to understand, are this, let's say, 200 theses in this area, are they all converging on some common topic? That would be possible, those kind of analysis. And I think that will give some very, very valuable insights with regard to, okay, X topic is what is being highlighted in traditional peer-reviewed literature, Y topic in preprints, and maybe Z topic in the dissertation. So, one could be considered as, more cutting edge, which is still not undergone traditional peer-reviewed. One could be something which is more of interest in academic levels, which are dissertations not really made into manuscript. They're not transformed into manuscript. So this gives a researcher a lot of fodder to think about. What do I work on?
Sure. So definitely it's a very, very useful lecture to all the viewers who are present here on our social media platforms. Thank you very much, Ms. Subhasree Nag.
Sir, one more question, sir.
Yes, sir.
With it, one more. Your QR code I tried to scan. It's not going to that. It's going to QRF. Can you?
Okay, I can put it once again. So anybody who needs that paper, I'll just put the, so if you can just I put in my email ID. If you can just offline contact me, I'll just send a PDF of the paper. Sometimes, when we convert it into PPT, the QR codes lose their integrity. Somebody has asked us about patents and copyrights. Yes, there are patent databases, which I'm very happy to report that InflibNet UGC uses it, Derwent Innovation, for extracting the patents. Only one small, I would say, advice that I would like to give to all researchers and the university people regarding patents. What we have noticed is several Indian researchers do not list their host institution as the assignee. So if you are from IIT Madras, and let's say you have Smita Sharma from IIT Madras, what we notice is in the applicant field, it is Smita Sharma, and the address is given as IIT Madras. Whereas the applicant for a patent should have been IIT Madras. The host institution is always the applicant, whereas the inventor is a researcher. Now, why this is very important is, I'm sure Manoj sir will also agree with me, it makes searching for patents related to an institution very difficult for InflibNet and UGC while doing the rankings. So if this is a small good practice that can be highlighted to researchers, that please use the host institution name in the applicant field while applying for the patent, that will be very helpful.
Great. So we'll conclude here with thanks to Ms. Subhasree and all the audience who are